Alrighty, in the last video, I issued you the challenge to 2.2, create data loaders using automatically created transforms. And we'll put here, the same principle applies for automatic transforms. We want our custom data in the same format as a pre-trained model was trained on. Now, this will ensure we get the best performance possible. So if we jump into the documentation here, I'm going to go to the latest version, currently unstable. Your version may be stable, but just make sure it's version 0.13 onwards. We go into models and pre-trained weights, and this is the new multi-weight support API. So if we look into here, there's now a way to make transforms. Yeah, here we go, beautiful. So we can initialize the transforms required to use a certain pre-trained model from the weights of that pre-trained model. So say we wanted to use ResNet 50, which is a computer vision architecture, we could get its weights and the default weights. Recall that default means best. And in fact, this is some of your extra curriculum here, is to make sure you read through the Torch Vision documentation, especially the models and pre-trained weights section, because it's so valuable for transfer learning. And then if we take those weights, we can call the transforms method on the weights and then use those transforms to pre-process an image. So let's see this in action. If we go to classification, we've got a whole bunch of different model options here. We're going to use EfficientNet because we've seen it work quite well in the past. And we're going to stick with EfficientNet B0. And we want, there we go, Torch Vision models, EfficientNet B0 weights. So let's see this in action. We'll come back to the notebook, and we did this in this section, so you might have already given this a go, and if you did, I applaud you. Otherwise, let's practice together. Equals, we don't need to recreate this, we're just doing it for completeness, so both of these cells are complete on their own. Equals image path / test. Now, here's our step that's a little bit different, is we're going to set up the pre-trained weights. So there are plenty of these weights available in Torch Vision .models, and now it needs to be version 0.13 plus. That's why we spent some time up here installing the latest versions of Torch Vision. Your Google Colab instance might already have them by default. So let's jump back down here. So we can come into here. If we wanted to select a different model, we could try it. The process is going to be very similar regardless of the pre-trained model you use. We've got a bunch of them here. And we've also discussed that oftentimes you want the best trade-off between performance, accuracy level, and number of parameters. And EfficientNet offers a pretty good balance there. So pretty good performance, accuracy with a lower number of parameters. So we'll jump back into EfficientNet B0 weights, and then we can get this and copy that. We'll come back to here. So from Torch Vision, import models. We didn't necessarily need to do that. We could just go import Torch Vision actually, import Torch Vision. I just want you to be able to see where all of these things are coming from. So let's set up our weights. Is going to be torchvision.models. I copied this for a reason, because sometimes you have to get the cases correct, otherwise you'll get errors. So we're just copying that down there. And then I'm going to call .default, which means default is the same as best available. So the beautiful thing about the updated version of the PyTorch Torch Vision multi-weight API is that if these weights ever get updated, so PyTorch train a new recipe of EfficientNet B0, or in fact any of the other models in torchvision.models, we can use the updated version of the weights. So if these get better, that means we get to use those improvements. So let's keep pushing forward. We'll get the transforms from weights. So these are the transforms used to train a particular or obtain a particular set of weights. So pre-trained weights, pre-trained patterns, depending on the model architecture. So automatic transforms equals weights dot, we'll call the transforms method. So we're getting some pre-trained weights here for EfficientNet B0, the default ones, the best available, and we're getting the transforms that we need that were used to create these weights. Why? Because we want our custom data, if we're going to be using transfer learning, we want our custom data to be in the same format as the pre-trained models we're trained on. So we'll go test data loader. Now we're going to create the data loaders. We're going a little bit faster pace this time because we have covered this material before, but nothing like a little bit of practice. So trained-er equals our trained-er. Our tester equals tester. And we could do a little printout, actually. I might do that as well. So our transforms is going to be the automatic transforms, and our batch size is going to be the ever-reliable 32. You could, of course, customize these settings. Let's print out. Oh, this is meant to be an F string. So we'll go here. Automatically created transforms. This will be our automatic transforms. Automatic underscore transforms. Beautiful. And then we will have a look at here. Train data loader, test data loader, class names. Let's see what's going on. Oh, what did we get? A little typo. Did you notice that? We had triander. Wonderful. And we see that our automatically created transforms are basically the same as our manually created transforms. The only difference here is that for manual creation, you have a bit more flexibility in how you create them, so you could add some more steps in here if you wanted to. However, you just have to make sure they're not too different from the pre-trained model that we'd like to use. Otherwise, there might be some performance degradation. The benefit of using automatically created transforms based on the model weights you'd like to use is that, well, they were used for that model weight. So you know that if your data goes through here, that it will be in the same format as what this model was trained on. So with that being said, speaking of getting pre-trained models, how about in the next video, we get a pre-trained model, we freeze the base layers, and we change the classifier head to suit our problem. In fact, we've already done this in Section 6, PyTorch Transfer Learning, Section 3. So I'd encourage you to go through here, try to get an EfficientNet B0, freeze all of its base layers, and change the classifier head to suit our own problem. Give that a go, and I'll see you in the next video. We'll try it out together.